latest Caldera Chronicles, USGS explains Yellowstone Supervolcano hydrothermal explosions are hidden beneath the Lake Serene waters. This is from USGS Caldera Chronicles, December 28, 2020. Although Yellowstone Lake itself may seem calm, the floor of the lake is littered with hydrothermal explosion craters. Now we know the lake is sitting right on top of the roof of the magma chamber, the chamber sitting on top of the magma reservoir, which geologists claim stretches all the way down to the border of US with Mexico. Now the chamber, the roof of the chamber, is only 3 miles down. So if you've ever visited the Yellowstone Lake area, 3 miles down is the roof of the magma chamber. Now, the detailed studies are beginning to reveal the details of these explosions, like the one that formed Elliott's crater about 8,000 years ago. Hydrothermal explosions are considered one of the most serious natural hazards in Yellowstone. On land, hydrothermal explosion craters, and especially large ones, hundreds of meters in diameter, are easily identified. Within the Yellowstone caldera, their bowl-shaped expressions are commonly filled with lakes surrounded by raised rims composed of explosion breccia ejecta. And well-known explosion craters in Yellowstone include Pocket Basin and Lower Geyser Basin, Turbid Lake, and Mary Bay craters north of Yellowstone Lake. Their explosions occurred thousands of years ago and were extreme events where boiling water, steam, hot mud, and rock fragments up to several meters in diameter were ejected hundreds of meters above the crater and rained down on the landscape. Visitors can see those craters today, but what about those craters that cannot easily be seen beneath the waters of Yellowstone Lake? Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. Elliott's crater is one of multiple explosion craters on the floor of Yellowstone Lake, a beautiful, serene-looking large pond of water that straddles the southeast margin of the Yellowstone caldera. Of the many fascinating discoveries that have been made in Yellowstone Lake, identification of hydrothermal explosion craters is one of the more significant. Until a detailed bathymetric mapping campaign, coupled with collection of seismic reflection profiles in 1999 to 2003, the large 838-meter diameter Elliott's crater hydrothermal explosion crater in the northern part of the lake was not known. A crater named after Henry Elliott, the first to conduct soundings on Yellowstone Lake as part of the 1871 Hayden Survey, is a large feature in the northern lake. Despite the crater being less than 2 kilometers south of the northern lake shoreline, no deposits of this explosion have been mapped on land, whereas hydrothermal explosion deposits from the 13,000-year-old Mary Bay and the 9,400-year-old Turbid Lake and the 2,900-year-old Indian Pond explosion events are well exposed. So you can see that we've had tremendous hydrothermal explosions since the 70,000-year lava explosion and another 80 explosions of Yellowstone since that 70,000-year explosion. These are hydrothermal explosions. This is not lava explosions, obviously. Now, recent piston corings of efforts of the lake floor, done as part of the National Science Foundation funded and USGS and National Park Service supported Hydrothermal Dynamics of Yellowstone Lake project, have identified a set of findings, finding upward sedimentary sequence tens of centimeters below the Mazama ash, which was deposited when Crater Lake formed in Oregon 7,600 years ago. This finding upward sequence is interpreted as a hydrothermal explosion breccia from Elliott's crater based on the deposit's distinct hydrothermal chemical signature and physical properties relative to other lake sediments, as well as its distinct hydrothermal altered rock composition and age. Material from the explosion deposit is extremely altered, indicating that pervasive hydrothermal activity occurred at this site prior to the explosion. The age of the Elliott crater's explosion event originally was estimated to be 8,000 years old, based on assumed northern lake sedimentation rates. That's 1 meter per 1,000 years. That's about 3 feet every 1,000 years. The thickness of deposits and the crater from seismic reflection profiles. In the sediment cores, stratigraphic position combined with new radiocarbon ages also support an age close to 8,000 years. Composition, mineralogy, thickness, and distribution of the Elliott crater's explosion deposit prove that it originated at Elliott's crater, and physical sorting of the deposit indicates the explosion was deposited in water. This, plus studies of traces and terraces north of the lake, indicate the explosion occurred underwater at about 20 meters water depth. That's about 60 feet down. A detailed examination of the deposit reveals that the hydrothermal explosion generated at least 3 pulses separated by 40 to 160 years, showing that it was the most intense explosion. Each subsequent explosion decreased in intensity, as reflected by decreasing clast size and thickness of the primary deposits. Based on the distribution and cumulative thickness of the Elliott's crater explosion deposit, debris from the explosion was directed south and somewhat west to the source crater. Crater rim heights vary from north to south by 6 to 10 meters and suggest an ejection angle that directed most of the deposit to the south. This explains why no exposures of the Elliott crater deposit are along the northern shore of Yellowstone or along the eastern or western shorelines. Today, Elliott's crater remains hydrothermally active. In fact, Elliott's crater contains several smaller craters on the western and southern areas of the crater floor. Recent imaging and sampling of active hot hydrothermal vents inside and along the edge of Elliott's crater indicate this feature has been active for over 8,000 years and will continue to be active into the future. Exploration and discovery in Yellowstone Lake opens our eyes to previously unknown hydrothermal activity, and the lake sediments preserve features that cannot be studied by other means, allowing us to understand the process that create these events. So you can understand that even these underwater hydrothermal explosive areas are dangerous in the area of Yellowstone. It's not just the magma. So this is from USGS. Thank you for your support and leave your comments. Thank you so much.